Picture this moment right now. You're deciding whether to keep watching this video or scroll away. You feel like you're making a choice, don't you? You feel that sense of control, that power to decide your own fate. You believe that in this very instant, multiple futures are possible, and you, through your free will determine which one becomes real. But what if I told you that feeling is completely wrong? What if every choice you think you're making was already determined the moment the universe began? What if free will, that most precious human belief, is nothing more than a beautiful, comforting illusion? For over 2,000 years, the greatest minds in human history have wrestled with this question. Do we truly choose our actions, or are we just sophisticated biological machines, executing a program written by the laws of physics? For centuries, it seemed like science was moving toward a disturbing answer. The universe appeared to be a giant clockwork mechanism, where every event was the inevitable result of what came before. Isaac Newton's laws painted reality as a cosmic billiard table, where if you knew the exact position and momentum of every particle in the universe, you could predict the future with perfect accuracy. The French mathematician Pierre-Simon Laplace took this idea to its terrifying logical conclusion. He imagined a superintelligent being that could know the precise location and momentum of every atom in the universe. This being, he claimed, could predict every future event and retrodict every past occurrence. The future would be as fixed and determined as the past. This was determinism in its purest, most suffocating form. Your decision to watch this video wasn't really your decision at all. It was simply the inevitable result of a chain of cause and effect that began with the Big Bang. Every thought in your head, every feeling in your heart, every choice you think you make was predetermined by the initial conditions of the universe billions of years ago. But then, in 1927, a young German physicist named Werner Heisenberg discovered something that would shatter this deterministic worldview forever. Something so revolutionary, so fundamentally disturbing, that it forced us to completely reconsider the nature of reality itself. Heisenberg wasn't trying to save free will. He was just trying to understand atoms. But what he found in the quantum realm would have implications far beyond physics. He discovered that the universe, at its most fundamental level, refuses to be predictable. It refuses to be determined. And in that refusal, he may have accidentally proven that free will isn't just possible, it's written into the very fabric of reality. Here's what Heisenberg discovered, and why it changes everything. He was studying electrons, those tiny particles that orbit atomic nuclei. But the more carefully he looked, the more puzzling things became. When he tried to measure exactly where an electron was located, something strange happened. The more precisely he determined its position, the less he could know about how fast it was moving. And conversely, the more precisely he measured its speed and direction, the more uncertain its location became. At first, Heisenberg thought this was just a technical problem. Maybe his instruments weren't good enough. Maybe he needed better technology, more sophisticated equipment. But as he dug deeper into the mathematics, he realized something shocking. This wasn't a limitation of his equipment. This wasn't a problem to be solved. This was a fundamental feature of reality itself. The universe, he discovered, places absolute limits on what can be known. Not just what we can know with our current technology, but what can be known in principle, by anyone, using any conceivable method, ever. This became known as the Heisenberg uncertainty principle, and it states that you cannot simultaneously know both the exact position and exact momentum of any particle with perfect precision. But here's where it gets really mind-blowing. This isn't just about measurement. This isn't about the limitations of scientific instruments or human knowledge. The particles themselves don't have definite positions and momenta simultaneously. It's not that we can't know these values, it's that these values don't exist until they're measured. Think about what this means. In the classical deterministic universe that Newton described, every particle had a definite position and momentum at every moment. If you could know these values for every particle, you could predict the future perfectly. But Heisenberg showed that these values simply don't exist in the way we thought they did. An electron doesn't have a definite path from point A to point B. It doesn't travel like a baseball through space, following Newton's laws. Instead, it exists in what physicists call a superposition of all possible paths simultaneously, until something forces it to choose one particular path. And that choice appears to be genuinely random, fundamentally unpredictable. Now, you might be thinking, so what? These are subatomic particles. What does this have to do with free will? I'm not an electron. I'm a human being made of trillions of atoms. Surely quantum uncertainty gets averaged out at the scale of human behavior. And for a long time, that's what most scientists thought. They believed that quantum effects were confined to the microscopic realm, and that the macroscopic world we experience still operated according to classical, deterministic laws. Your brain, made of billions of neurons, each made of trillions of atoms, seemed far too large for quantum uncertainty to matter. But this assumption is crumbling. We're discovering that quantum effects might play a crucial role in biological systems, including the human brain. Some researchers believe that consciousness itself might be a quantum phenomenon. Others suggest that the random quantum events in our neurons could be amplified into macroscopic effects that influence our thoughts and decisions. Consider this: your brain is constantly making decisions at the cellular level. Neurotransmitters cross synapses. Ion channels open and close. Electrical signals propagate through neural networks. Many of these processes occur at scales where quantum effects become significant. If even a tiny fraction of these microscopic events are truly random, genuinely unpredictable, then the deterministic chain is broken. But let's go deeper. Let's explore what determinism actually claimed and why Heisenberg's discovery destroys it so completely. Classical determinism rested on a simple but powerful idea. If you knew the exact state of the universe at any given moment, you could calculate its future states with mathematical precision. The universe was like a vast equation that, once solved, would reveal every future event. This idea seemed reasonable because everything we could observe appeared to follow strict mathematical laws. Planets orbited the sun in predictable ellipses. Pendulums swung with clockwork regularity. Cannonballs followed precise parabolic trajectories. Even human behavior, when viewed statistically, seemed to follow patterns that could be predicted and modeled. But Heisenberg revealed that this apparent predictability was built on a foundation of sand. At the quantum level, the universe is fundamentally random. Particles don't follow predetermined paths. They exist in clouds of probability until measurement forces them to crystallize into definite states. And these crystallizations appear to be genuinely random events, not just events that seem random because we lack information. This randomness isn't like flipping a coin. When you flip a coin, the outcome appears random to you because you don't know the exact initial conditions, the precise force applied, the air currents, the rotational speed. But in principle, if you had enough information, you could predict whether it would land heads or tails. Quantum randomness is different. It appears to be true randomness, inherent in the structure of reality itself. Now, some people argue that randomness isn't the same as free will. They say that if our decisions are based on random quantum events, then we're not really in control, we're just slaves to cosmic dice rolls. But this misses the crucial point. The existence of fundamental randomness means that strict determinism is false. It means that the future is not completely fixed by the past. And in that gap, in that space between strict determinism and pure randomness, something profound becomes possible. Free will doesn't require that our choices be completely It only requires that they not be completely determined by prior causes. Quantum indeterminacy provides exactly that wiggle room, that space for genuine choice. But the implications go even further. Heisenberg's uncertainty principle doesn't just apply to position and momentum. There are other pairs of properties that cannot be simultaneously measured with perfect precision. Energy and time, for example. This means that the universe can borrow energy from the vacuum for short periods, allowing virtual particles to pop into existence and then vanish again. These quantum fluctuations are happening everywhere, all the time, including in your brain right now. Every neuron in your head is subject to quantum uncertainty. Every decision you make is influenced by fundamentally unpredictable quantum events. The idea that your behavior is completely determined by prior causes becomes not just implausible, but mathematically impossible. Let me put this in perspective. Before Heisenberg, free will seemed to be in direct conflict with scientific understanding. As science advanced, and we learned more about the physical basis of human behavior, free will appeared increasingly unlikely. We discovered that brain injuries could dramatically alter personality. We learned that chemicals could influence mood and decision-making. We found that unconscious processes seemed to make decisions before conscious awareness kicked in. All of this evidence seemed to point in one direction. Human beings are sophisticated biological machines, operating according to the same deterministic laws that govern everything else in the universe. Free will was just a persistent illusion, a story we tell ourselves to feel better about our lack of control. But Heisenberg changed everything. He showed that the universe itself is not deterministic. At the most fundamental level, reality refuses to be predictable. This doesn't prove that free will exists, but it demolishes the primary argument against it. If the universe itself is not determined, then neither are we. Consider what this means for responsibility and ethics. If strict determinism were true, then no one would be truly responsible for their actions. A murderer would be no more responsible for his crime than an avalanche is responsible for burying a village. Both would be the inevitable result of prior causes, stretching back to the beginning of time. But if genuine indeterminacy exists in the universe, if quantum uncertainty allows for real choices, then responsibility becomes possible again. Not absolute responsibility, we're still influenced by our genes, our upbringing, our circumstances. But genuine responsibility, grounded in the fact that we are not completely determined by our past. This has profound implications for how we think about criminal justice, moral education, and personal development. If we have genuine choice, even if it's constrained and influenced by many factors, then we can be held accountable for our actions. We can meaningfully strive to improve ourselves. We can create better futures through our decisions. But here's where the story gets even more interesting. Heisenberg himself struggled with the philosophical implications of his discovery. He realized that quantum mechanics didn't just describe the behavior of particles, it revealed something fundamental about the nature of observation and reality itself. The act of measurement, Heisenberg realized, doesn't just reveal the properties of quantum systems, it actually creates them. Before measurement, an electron doesn't have a definite position. After measurement, it does. The observer becomes an integral part of the observed system. Reality becomes observer-dependent in a way that seems to give consciousness a special role in the universe. This suggests that consciousness might not be just an emergent property of complex matter, but something more fundamental. If consciousness plays a role in collapsing quantum possibilities into definite realities, then free will might be built into the very structure of the universe. Every conscious observation, every conscious choice, might be an act of creation, a moment when possibility becomes actuality. Now, I want to address a common objection to this line of reasoning. Some people argue that quantum effects in the brain are too small and too random to give rise to meaningful free will. They claim that thermal noise at body temperature would quickly destroy any quantum coherence, making quantum effects irrelevant to neural processing. But this objection is based on outdated assumptions about how quantum effects work in biological systems. We're discovering that living systems have evolved sophisticated mechanisms to protect and exploit quantum coherence. Photosynthesis, for example, appears to use quantum superposition to achieve near-perfect energy transfer efficiency. Bird navigation might depend on quantum entanglement in certain proteins in their eyes. If evolution has found ways to harness quantum effects for biological purposes, why wouldn't it have found ways to incorporate quantum indeterminacy into decision-making processes? The brain is not a classical computer operating at the mercy of thermal noise. It's a quantum classical hybrid system, capable of amplifying microscopic quantum events into macroscopic consequences. Consider also that free will doesn't require that every aspect of our behavior be undetermined. Even if only a small fraction of our neural activity involves genuine quantum indeterminacy, that could be enough to break the chains of strict determinism. A tiny quantum event in a critical neuron at a crucial moment could cascade into a completely different decision, a different action, a different future. This is reminiscent of chaos theory, where tiny changes in initial conditions can lead to vastly different outcomes. But while chaos theory deals with deterministic systems that are simply too complex to predict, quantum mechanics deals with genuinely indeterminate systems. The uncertainty isn't just practical, it's fundamental. And here's perhaps the most mind-bending aspect of all this. If quantum mechanics is correct, then the future literally doesn't exist until it's created. The universe is not unfolding according to a predetermined script. It's being written moment by moment, decision by decision, observation by observation. Every time you make a choice, you're not just selecting from pre-existing alternatives. You're participating in the creation of reality itself. The future is not a fixed destination that you're traveling toward. It's a landscape that you're helping to shape with every step you take. This view of reality is both empowering and terrifying. It means that we have genuine responsibility for the kind of universe we create. Our choices matter not just for our own lives, but for the fundamental structure of reality itself. We are not passive observers of a predetermined cosmic drama. We are active participants in its creation. But let's be clear about what this doesn't mean. The existence of quantum indeterminacy doesn't mean that anything is possible. Physical laws still constrain what can happen. Your choices are still influenced by your genes, your experiences, your environment, and countless other factors. Free will, if it exists, operates within constraints. Think of it this way. A jazz musician improvising a solo has genuine creative freedom, but that freedom operates within the constraints of the chord progression, the rhythm, the capabilities of the instrument, and the musician's own skill and knowledge. The improvisation is neither completely determined nor completely random. It's a genuine creative act, constrained but not controlled by the circumstances. Similarly, human free will might operate within the constraints of physical law, genetics, and experience, while still allowing for genuine choice and creativity. Quantum indeterminacy provides the space for this kind of constrained freedom. It breaks the chains of strict determinism without descending into pure chaos. And here's something else to consider. If consciousness plays a role in quantum measurement, then every conscious being might be a creator of reality. Your thoughts, your observations, your decisions might literally be shaping the universe. This isn't mysticism or wishful thinking. It's a serious possibility that emerges from our best current understanding of quantum mechanics. Of course, we're still far from fully understanding the relationship between quantum mechanics and consciousness. The hard problem of consciousness, how subjective experience arises from objective matter, remains unsolved. But the mere possibility that consciousness might be fundamental to the universe, rather than just an emergent property of complex matter, changes everything. If consciousness is fundamental, then free will becomes not just possible, but inevitable. A universe that is constantly being shaped by conscious observation and choice is a universe where determinism cannot be absolute. Every moment of conscious experience becomes a moment of creation, a fork in the road of possibility. This brings us to perhaps the most profound question of all. If we do have free will, if our choices genuinely matter, what should we do with this awesome responsibility? How should we live in a universe where our decisions help create reality? Heisenberg himself grappled with these questions. Not just as a physicist, but as a human being, living through one of the most turbulent periods in human history. He lived through 2 world wars, the rise and fall of Nazi Germany, and the development of nuclear weapons. He saw firsthand how human choices could reshape the world, for better and for worse. And he understood that with the power to choose comes the responsibility to choose wisely. In a determined universe, there would be no point in trying to improve things. Whatever happens would happen regardless of our efforts. But in an indeterminate universe, where genuine choice is possible, we have both the opportunity and the obligation to make good choices. This responsibility extends beyond our personal lives to the collective future of humanity. If our choices genuinely shape reality, then we have a role in creating the kind of world we want to live in. Every act of kindness, every moment of courage, every decision to do what's right, rather than what's easy, contributes to the fundamental structure of the universe. And this brings us full circle to where we started. That feeling you have of being able to choose whether to keep watching this video, or scroll away, that feeling might not be an illusion after all. It might be your most fundamental connection to the creative power of the universe. Your choice might be a small but real act of creation, a moment when possibility becomes actuality. The implications of Heisenberg's uncertainty principle extend far beyond the laboratory. They touch the deepest questions of human existence. Who are we? Do our choices matter? Are we masters of our own destiny, or just sophisticated puppets dancing to the tune of physical law? Heisenberg's answer, whether he intended it or not, is profoundly hopeful. We are neither gods nor puppets. We are something more interesting and more complex. We are conscious beings with limited but genuine freedom, operating in a universe that is neither completely determined nor completely random. We are improvising musicians in the cosmic jazz session of existence. The uncertainty principle doesn't just describe the behavior of electrons. It describes the fundamental openness of the future. It tells us that prediction has limits, that control has boundaries, that surprises are always possible. In a universe governed by uncertainty, every moment contains the possibility of something genuinely new. And that's perhaps the most beautiful irony of all. Heisenberg set out to understand the predictable, mathematical laws of atomic behavior. Instead, he discovered that unpredictability is itself a law of nature. He sought certainty and found uncertainty. And in that uncertainty, he may have found the foundation of human freedom. So the next time someone tells you that free will is an illusion, that your choices don't matter, that everything is predetermined by the laws of physics, you can tell them about Werner Heisenberg. You can tell them about a young German physicist who looked into the heart of an atom and found a universe that refuses to be completely known or completely controlled. You can tell them that the universe itself chooses uncertainty over determinism, possibility over fate, freedom over slavery to the past. And in making that choice, it opens up space for all of us to choose as well. The future is not written. It's being written, word by word, choice by choice, moment by moment. And you are one of its authors. Use your pen wisely.